Imagine you're standing at the edge of time, gazing down a long, unbroken line stretching from the past to the future. The present, always fleeting, slips away as you move forward, while the future remains an unknown horizon. This linear perspective has shaped how we think about life, existence, and even the universe itself. Linear time. Linear time is the belief that time flows in one continuous direction, from the past, through the present, and into the future. It's a worldview that has greatly influenced Western thought for centuries, suggesting that time moves like a river, with no going back. Once something passes, it is gone forever. In this view, time is an irreversible journey from the beginning to the unknown end. In ancient Egypt, time was seen as cyclical: life, death, and rebirth. However, Western philosophy began to develop the concept of linear time, particularly in the Babylonian period, and later in Judeo-Christian theology. Here, time was seen as a progression with a defined start and end. The Bible is one example. Creation and the apocalypse describe the beginning and the end, solidifying the idea of time moving forward. Philosophers like Plato and Aristotle argued that time is linear. Plato believed time was a moving image of eternity, while Aristotle viewed time as a constant flow from past to present to future, governing the changes in the world. Their thinking solidified time as an external force, moving in one direction, determining the fate of all things. Christianity played a huge role in shaping linear time. In Christian thought, time is created by God, with a clear beginning, the creation, and a future end, the second coming of Christ. Time becomes more than a measure. It becomes a divine narrative, where human history is seen as a journey towards salvation, with a clear path from creation to judgment. Example: the book of Revelation details the ultimate end of the world, reinforcing the idea that time moves toward a fixed conclusion, where everything culminates in an eternal state. During the Enlightenment, philosophers like Isaac Newton proposed a scientific understanding of linear time. Newton argued that time flows uniformly for everyone, and that it exists independently of human perception or events. His view suggested that time was a constant, a universal backdrop to the unfolding of the universe. Example from science. Newton's theory introduced the idea that time flows uniformly, like a ticking clock, unaffected by anything happening in the universe. His model treated time as a fundamental, measurable dimension. Although linear time may seem fixed, we often perceive it subjectively. Time feels like it moves at different speeds depending on our emotions or activities. When we're enjoying ourselves, hours fly by, but when we're bored or waiting, minutes seem to stretch on forever. Example: waiting for a train might feel like an eternity, but during a conversation with a friend, those same minutes fly by unnoticed. Our internal experience of time often differs from its external, linear measure. Cultural implications of linear time. In Western culture, the belief in linear time influences ideas of progress. We talk about advancing in technology, society, and our personal lives. Linear time implies that we are always moving forward, improving, and moving towards something better. This view of time drives much of modern life. Example: think about the Industrial Revolution or the digital age. The drive to progress is based on the assumption that time is linear, and that each step forward leads to a better, more efficient future. Despite its dominance, linear time has been challenged by philosophers like Henry Bergson. He argued that time is not just a mechanical ticking clock, but something deeply personal. Bergson's idea of la durée, duration, suggests that time is experienced internally, subjectively, and cannot be reduced to a simple sequence of events. Example: Bergson's view suggests that time should not be seen merely as a series of events, but as a continuous experience that we live through in a personal, emotional way. Time isn't fixed or uniform, but feels different depending on our internal state. Conclusion. Linear time remains a dominant concept in both our daily lives and our understanding of the universe. It shapes how we view history, progress, and even our own existence. But as we reflect on our experiences and engage with different philosophical ideas, it becomes clear that time might not be as linear as we think. Do you see time as a straight line, always moving forward, or do you sense it's something more fluid, shaped by your personal experiences and emotions? Cyclical time. Imagine time not as a straight line, but as a circle, an eternal loop. Everything repeats: life, death, and the seasons. What if the universe itself moves in endless cycles, with the past forever returning in the future? Cyclical time is the belief that time doesn't move in one direction, but instead repeats in endless cycles. Unlike linear time, which suggests a one-way progression, cyclical time views existence as a never-ending loop where events, states, and experiences recur. Many ancient cultures and philosophies embraced this view, believing that time and life are part of a grand repetitive rhythm. One of the earliest conceptions of cyclical time comes from ancient Hinduism and Buddhism. In Hindu thought, time is divided into yugas, cycles of creation and destruction. After the Kali Yuga, the world begins anew in another cycle. Similarly, in Buddhism, time is viewed as samsara, a cycle of birth, death, and rebirth, with the goal of escaping the loop and achieving nirvana. Ancient philosophers like Heraclitus suggested that life is a constant flow, hinting at the idea of cycles. His view of flux suggested that everything is in a state of perpetual change, part of an ongoing process that eventually repeats. Nietzsche took this further with his concept of eternal recurrence, arguing that every moment repeats infinitely. If we knew everything would return, would we live our lives differently? Cyclical time is reflected in nature, where the seasons, the moon's phases, and even life cycles follow predictable patterns. The annual changes in nature mirror the cyclical nature of time, showing that life isn't just linear, but follows recurring phases. Example: the changing seasons, from spring to winter, represent time's cyclical nature. Just as nature regenerates itself every year, time flows in a similar repeating pattern. Many ancient civilizations, especially in the East, viewed time through a cyclical lens. The ancient Maya, for instance, saw time as a series of interlocking cycles, with the end of each cycle marking the start of another. Similarly, the Egyptians linked the concept of cyclical time with the flood of the Nile, symbolizing renewal and death followed by rebirth. Although cyclical time was overshadowed by linear thinking, it still resonates in modern discussions. The Big Crunch theory in cosmology suggests the universe may collapse in on itself and repeat the Big Bang, offering a cosmic perspective on cyclical time. Some physicists even propose that the universe might go through endless cycles of birth and rebirth. Our personal experiences often reflect cycles. We go through recurring habits, emotions, and routines, much like the seasons. We experience cycles of joy, struggle, and growth, where certain themes seem to repeat in different forms throughout our lives. Example: many people feel they go through cycles in their lives, such as career changes or emotional growth. These repetitions shape how we understand time on a personal level. In linear time, the end of the world is a final event. In cyclical time, the end is just another beginning. The end of one cycle leads to the rebirth of the next. Ancient myths often reflect this, where destruction leads to renewal. Example from mythology: in Hinduism, after the Kali Yuga ends, a new cycle begins with the Satya Yuga. This represents the eternal nature of time, where even destruction is part of a regenerative process. Science fiction often explores cyclical time, with stories about time loops and eternal recurrence. Films like Groundhog Day and shows like Russian Doll depict characters caught in repeating events, illustrating the philosophical implications of time repeating itself endlessly. Conclusion: cyclical time offers a refreshing contrast to linear time, suggesting that life is a perpetual rhythm of birth, death, and rebirth. Ancient cultures, modern cosmology, and even our personal experiences all point to the idea that time is not just a straight path, but a repeating cycle. Do you feel trapped in cycles in your own life? How would you live differently if you believed your actions would repeat forever in an eternal loop? Time as an illusion. Imagine time is nothing more than an illusion. That past, present, and future are mere constructs of our mind, and time itself doesn't truly exist. What if everything you've experienced was just a fleeting perception, a trick of the mind? The concept that time is an illusion challenges our basic understanding of reality. Time, in traditional sense, is often seen as a steady, universal force that flows from the past into the future. But some philosophies, both ancient and modern, suggest that time may not be an independent entity at all, but a mental construct created by our minds. Heraclitus, an ancient Greek philosopher, argued that everything is in constant flux, and our perception of time is merely a limited view of this constant change. In Eastern traditions like Hinduism and Buddhism, time is considered illusory or cyclical. Time, in this sense, is just a veil over a deeper, eternal reality. Immanuel Kant proposed that time is not an external reality, but a way our minds organize experiences. According to Kant, time is not an objective feature of the world, but a framework that the human mind imposes in order to make sense of events. Without consciousness, events would have no inherent order or meaning. Linear time, the belief that time flows from past to present to future, is another concept that could be illusory. Albert Einstein's theory of relativity suggests that time is not absolute, but relative. Time can appear to move differently depending on an observer's speed or position. This relativistic view shows that our perception of time is not a universal truth, but one that depends on perspective. Einstein's theory of relativity challenges the notion of absolute time. He showed that time can warp depending on factors like gravity and motion. This implies that time is not the same for all observers, further supporting the idea that time might be a construct of our minds, shaped by our experiences and environment. Quantum mechanics further complicates the understanding of time. At the quantum level, particles do not behave in predictable, linear ways. Events in the quantum world can occur simultaneously, and time itself seems less fixed. In quantum physics, time is not a straightforward concept, and may be just a mental framework that helps us navigate our perception of reality. Quantum entanglement is a phenomenon where particles become linked, with their states instantaneously affecting each other, no matter the distance. This suggests that time does not operate in a linear fashion at the quantum level, and challenges the idea that time is a constant, fixed entity. If information can be transferred faster than the speed of light, time might not be as important as we think. On a psychological level, time is experienced very differently by each individual. When we are engaged in activities we enjoy, time seems to pass quickly. When we are bored, it seems to drag. This subjective experience of time suggests that it is not an objective reality, but a mental construct, shaped by our thoughts, emotions, and circumstances. Our memories are essential to our experience of time. We rely on memory to form a sense of past, present, and future. However, memory is unreliable. It changes over time. This malleability of memory indicates that our perception of time is flexible and constructed, not necessarily accurate or real. If time is an illusion, could it cease to exist? Some philosophers have speculated that time may end in the distant future, perhaps when the universe reaches a state of equilibrium or undergoes a big crunch or heat death. This suggests that time may not be an eternal feature of the universe, but a temporary phenomenon that could eventually dissolve. Conclusion: the idea that time is an illusion opens up many questions about the nature of existence. If time is merely a construct of the mind, what does that mean for our experiences, our choices, and our understanding of reality? By examining time through the lens of philosophy, science, and psychology, we are forced to confront the possibility that time is not what it seems. It may be nothing more than an illusion created by our consciousness. What if time is just an illusion we create in our minds? How would that change the way you view your past, present, and future? The theory of relativity and time. Imagine that time doesn't flow the same for everyone. What if your experience of time could change depending on how fast you move or how close you are to a massive object? Welcome to the world of Einstein's theory of relativity. Before Einstein, time was seen as fixed and universal. However, his theory of relativity revolutionized this idea. Time is not constant, but depends on factors like speed and gravity. Einstein showed that time and space are connected in a way that changes based on your motion or the gravity you experience. Einstein's special relativity tells us that the faster you move, the slower time passes for you compared to someone who's stationary. This is known as time dilation. For example, if you were traveling at near light speed, you would age slower than someone on Earth. This has been confirmed with high-speed particles that decay more slowly at high velocities. Imagine two twins. One stays on Earth while the other travels at near light speed. When the traveling twin returns, they will have aged less because time for them moved slower due to their speed. This has been proven in experiments with particles and is a fundamental result of special relativity. General relativity extends the ideas of special relativity to include gravity. Einstein showed that gravity isn't a force, but a warping of space-time caused by mass. Large objects like planet stars warp the space-time fabric, and this warping causes what we feel as gravity. An important insight of general relativity is that gravity also affects time. The stronger the gravitational field, the slower time moves. For example, a clock on the surface of the Earth runs slower than one in orbit, where gravity is weaker. This phenomenon is known as gravitational time dilation. A twin near a black hole would experience time much slower than one on Earth. In the twin paradox, if one twin stays on Earth and the other travels close to a black hole, the traveling twin will age slower. When they reunite, the twin near the black hole will be younger, despite experiencing the same amount of time in their own frame of reference. This is a direct consequence of gravitational time dilation. Relativity also tells us that nothing can travel faster than light. As objects approach the speed of light, time slows down even more. But it's impossible to reach light speed, as it would require infinite energy. This constant speed of light is crucial for understanding time dilation. Space and time are not separate entities, but are intertwined in a four-dimensional continuum called space-time. Massive objects warp this fabric, and this warping causes gravity. For example, imagine a heavy ball placed on a trampoline. The ball causes a dip in the surface, and smaller objects roll toward it. This is similar to how gravity works in the universe. Relativity is not just theoretical. It's used in everyday technology. For example, GPS satellites orbit Earth at high speeds and experience different gravity than objects on Earth. These differences must be accounted for in calculations to ensure GPS accuracy. Without correcting for relativity, GPS would be off by several kilometers. Relativity has changed how we view time. It's no longer an absolute, fixed entity, but something that can shift depending on your speed or the gravitational forces around you. This challenges our everyday experience of time and helps us understand the universe in new ways. Conclusion: Einstein's theory of relativity has revealed that time is not fixed. It changes depending on your motion and the gravitational forces at play. This has transformed our understanding of time, space, and the universe, showing that our everyday experiences of time are just a small part of a much larger, more complex reality. Imagine if you could travel at near light speed or live near a black hole. How would your perception of time and life change, knowing that time moves differently for you than for someone far away? Quantum time. Imagine if time didn't flow smoothly like a river, but instead was made up of tiny, discrete steps. What if time itself could be quantized, just like energy and matter? Welcome to the strange world of quantum time. In classical physics, time is seen as a continuous entity. However, quantum mechanics, the theory that governs the behavior of particles at the smallest scales, challenges this view. Time might not flow smoothly, but instead could be quantized, composed of discrete units like energy. This idea is explored in the search for a theory of quantum gravity, which aims to combine quantum mechanics and general relativity. In quantum theory, time is treated as an external, unchanging parameter. However, some physicists argue that time itself may not be a constant, as the rest of quantum mechanics is based on probabilities and wave functions. There's speculation that, much like other properties in quantum mechanics, time may exist in a superposition of different states and only collapse into a definitive moment when measured. In quantum mechanics, particles exist in a superposition of multiple states until they are observed. This principle might also apply to time. It suggests that events don't occur at exact fixed times, but exist in a superposition of potential moments, with the actual moment being determined upon observation. It suggests that events don't occur at exact fixed times, but exist in a superposition of potential moments, with the actual moment being determined upon observation. When attempting to reconcile quantum mechanics with general relativity, time becomes even more complex. One leading theory is loop quantum gravity, where space-time is thought to be made of tiny discrete units. These atoms of space-time suggest that time may be quantized as well, composed of discrete ticks at the Planck scale, the smallest meaningful unit of time. The Planck time is the smallest possible time interval that has any physical significance. Below this scale, our current understanding of physics breaks down. The Planck time represents the point after the Big Bang, when quantum gravitational effects were dominant. If time is quantized, its smallest measurable unit would be the Planck time, where the very fabric of space-time is in a quantum state. In quantum cosmology, some theories suggest that time itself might not have existed before the Big Bang. Instead, there could have been a quantum foam of fluctuating states, with no clear past, present, or future. Time as we understand it might have emerged from these quantum fluctuations after the Big Bang as the universe expanded. Some theories propose that time may not be a fundamental feature of the universe, but an emergent property that arises from deeper quantum processes. Similar to how temperature arises from molecular motion, time might emerge from the interactions of quantum particles, making it not a primary concept, but one that arises from more fundamental interactions. One of the biggest mysteries of time is why it flows in one direction, from past to future. In quantum mechanics, the equations are time reversible, meaning they allow time to move backward without violating any laws. Yet, we perceive time to have a clear direction, which is explained by the second law of thermodynamics, which states that entropy increases over time. The question is how this macroscaro of time emerges from the reversible, microscopic quantum world. The uncertainty principle in quantum mechanics tells us that we cannot simultaneously know certain pairs of quantities, like a particle's position and momentum. This might extend to time as well. If time is quantized or subject to quantum fluctuations, we may never be able to pinpoint the exact moment an event occurs, just as we cannot know a particle's exact position and momentum at the same time. Researchers continue to explore the nature of quantum time, with theories like loop quantum gravity, string theory, and others offering possible explanations. A complete theory of quantum gravity that merges quantum mechanics and general relativity may one day provide the key to understanding time at the most fundamental level. Conclusion: quantum time challenges our traditional understanding of time as continuous. Time may not flow smoothly, but instead be discrete and subject to quantum uncertainty. Whether time is quantized, emergent, or a product of quantum fluctuations is still unknown, but the exploration of quantum time could reshape our entire understanding of the universe. If time is quantized, how would our perception of reality change? Could our everyday experience of time be an illusion? Conclusion of video. As we've delved into today, the nature of time is far more complex than our everyday experiences suggest. From the linear flow of time we feel in our daily lives to the strange quantum nature that challenges our very understanding of reality, time is not just a simple progression of moments. Whether it is quantized into discrete units, emerges from deeper quantum processes, or exists as an illusion, time continues to elude a clear definition. Each of the theories we've explored, from the cyclical patterns of ancient thought to the mind-bending possibilities in quantum mechanics and relativity, shows just how much more there is to learn about this fundamental aspect of our existence. What if time as we know it is just a byproduct of our limited perception? What if time is far stranger, more complex, and more intricate than we could ever imagine? As we continue to push the boundaries of science and philosophy, we may one day discover that time, in all its forms, is not what we think it is. But for now, the mystery remains, and with it, the invitation to keep questioning, exploring, and contemplating the nature of time itself. So the next time you glance at your watch or reflect on the passage of time, take a moment to wonder, is time truly what it seems, or are we simply scratching the surface of a much deeper truth?